Right. This question 7.5. One end of a paddle is placed in water. The water applies a force to the paddle at the position shown in figure 10. This is our figure 10. The person applies a force of 84 newtons, which means this 84 newtons was the force applied by the person to the paddle, and this F was force applied by water, since it says the water applies a force of F, meaning that the water applied the force of F while the person applied the force of 84 newtons. Then now the question says the paddle does not turn. If you are confused, you don't know how to answer this question or which topic is this question belong to, whether maybe you're still confused of momentum, you're still confused of other questions, but what the hint is to check the force that are given and the key words like 10. If they talk about 10, if they talk about rotating, if they talk about moving clockwise, moving anti-clockwise, that has to do with the topic of moment. So now the question says to us, determine F. They want F, and F is the force. But before we get to that, I want us to understand one thing. I just want to give you a small basic about moment, just to remind ourselves about moment. So now we know that this question belongs to the topic of moment. Moment topic, we know about that now. So the question is, what is moment? Before we start doing the workouts and everything, you just remind yourself that moment, which means it's in capital letter M, or the symbol for moment is capital letter M, a big M, is equals to force multiplied by perpendicular distance. So what do I mean by that? Let's say we have a bar or a rod, and there's a force that was applied in this rod, and there is a pivot here that hold this rod. So if this person apply this downward force to the rod, it simply means that the rod will rotate in this direction, or will turn in this direction, of which this direction is what we call anti-clockwise. It rotates to anti-clockwise. So the distance between the point at which the force was applied, which is called the line of action, and to the pivot, it is perpendicular. Let's say the distance here is 3 meters. This distance is perpendicular to the line of action, or to the direction at which the force was applied. So then you use this distance. This is called the perpendicular distance. Why this is called the perpendicular distance? Because it is perpendicular to the line at which the force was applied, and that line is called the line of action. So now let's say the force is 10 newtons. 10 newtons was applied down anti-clockwise, and now we'll have moment is equals to force is our 10 multiplied by the perpendicular distance, of which is 3. Then our moment will be 30, right? And now I want us to check one thing. If we check here, this is the pivot. Remember, the perpendicular distance is from the pivot to the force, to the line of action, to the line to the force, which means from here, for an example, this one is from here to here. This is the perpendicular distance of this force. And now we check how about this distance from pivot to this force, which means this is the perpendicular distance of this force. Then how do you answer this question? This question, they told us that the paddle does not turn. Let's say we have two children, they are playing on a seesaw. We have children A here, child A, and we have child B. So now if the seesaw is not turning either direction, or it's not turning in this direction or is not turning in this direction, it means that the seesaw is balanced. These two students or these two children, they are balancing the seesaw. And for this seesaw to be balanced, it means that the moment, remember this is a pivot, it means that the moment applied in a clockwise direction is equal to the moment that is balanced, that is applied in the anti-clockwise direction. Therefore, if that's the case, it means that the seesaw will be balanced. It won't turn either direction. For example, let's say it means that the moment here, if the moment, it means the moment here maybe is 30 and this one is 30. Therefore, it's balanced. This seesaw will remain steady in this position, in this equilibrium position. It won't turn in either way, unless if a bigger child is replaced here, then you will see it will change maybe in this direction. Therefore, now it means it is not balanced. But the fact that this question, they told us that the paddle does not turn, it means that the paddle is balanced. And if the paddle is balanced, it means that the sum of the anti-clockwise moment is equal to the sum of the clockwise moment, as we've seen here in these two children when they are playing with the seesaw. I want us to try to answer this question. Now the question says find force F. Okay, then how do we do that? To do that, just want to change the color. I like this one. Good. To do that, the first thing we'll say the sum of the clockwise moment, sum of anti-clockwise moment is equal to, this is called the principle of moment, is equal to the sum of clockwise moment of the clockwise moment. Clockwise moment. Then now, what's the formula for finding moment? This is the formula for moment. I thought I changed the color. I want a new color. Give me a new color. Thank you. Good. Now let us check this. When this force is applied on the pedal will rotate in this direction. This is the pedal. If only this force was applied on the pedal, it means the pedal will have rotated in this direction, which means in this one direction. And if only this force was applied on the pedal, it means that the pedal would, wait, this one will rotate in this direction. How about this one? This one, the pedal will rotate in this direction. If this force is applied, it means the pedal will do this, meaning that this is it. So this one is clockwise, this one is anti-clockwise rotation. Anti, I need the rubber. This one is anti. Okay, thank you. I'll start again. And here, this one is anti-clockwise, and this one is clockwise. So, meaning that the clockwise moment is equal to anti-clockwise moment. Let's check the clockwise moment. What is the force for the clockwise moment? The force is 84 and the distance is 0.6. Therefore, we'll say 84 multiplied by 0.6 is equals to, for this one, the force is F. Remember, moment is force multiplied by perpendicular distance. And this is the force multiplied by this perpendicular distance. Then now we check here with this one, it will be the force, we don't know. We put F multiply, what is the perpendicular distance? The perpendicular distance is from the pivot to the force, or to the line of action. This is the pivot to this force, pivot to this force. So the moment for this one, it will be, the distance is, okay, the force is F, we don't know, and the distance is 1.60, 1.6. Then now, we want you to solve for F. Then how to solve F? We find the answer for this side is 84 multiplied by 0.6. Then we get 15.4 is equals to, this one is 1.6 F, 1.6 F. Then we want to remain with F this side. What do we do if we want to remain with F this side? So what do? We divide both sides by 1.6. This 1. And this side by 1.6. This 1.6 divides this, and I'm left with 50.4 divided by 1.6. Then the answer will be 31.5 is equals to F. Therefore, the force is 31.5 newtons. It is the force that is needed to balance this paddle, to make sure that this paddle is not rotating or is not turning. Right, guys, let's go to the next question.